So today we are going to be solving Cambridge IGCSE Chemistry Paper 43 Extended May June 2025 and Paper 43. So let's get started with this paper. Okay, a list of substances is shown. We have aluminum oxide, we have calcium oxide, chlorine, ethanol, graphite, nitrogen, oxygen, propene, and silicon IV oxide. Okay, so let's see what the question states. Answer the questions using the list of the substances. Each substance may be used once, more than once, or not at all. State which of the substances is a compound. Okay, so the first requirement is that it should be a compound, and the second thing says with a giant covalent structure. Okay, so now, how many giant covalent structures over here? First, we have a graphite, that's a giant covalent structure, and graphite is made up of carbon. And the second thing we have as a giant covalent structure is silicon IV oxide. So this is also a giant covalent structure. Now, giant covalent structures, we have two. But what we are supposed to do over here, we have to find the one that's a compound. And we know one thing for sure, that graphite is only carbon. So graphite is not a compound, it's carbon. So we are looking for a compound. Silicon IV oxide is made up of silicon and oxygen. So this is going to be a compound which is going to be SiO2. But you have to write the name that is basically given above. So it's going to be silicon IV oxide. Okay, next states is an unsaturated hydrocarbon. Unsaturation means that there has to be a carbon-carbon double bond. So let's see aluminum oxide. No. It's going to be either propane or propene. Okay, you should know that this ene part tells that there are going to be a carbon-carbon double bond. Propane is going to have no carbon-carbon double bond. It's going to have all single bonds. So this propene is going to have a carbon-carbon double bond. So it's going to be propene, and this ene part tells this is an amphoteric oxide. Amphoteric means that it can react with both acids and bases to form salt and water. So we know that there are only two amphoteric oxides in our syllabus. There's aluminum oxide and the second one is zinc oxide. So over here is aluminum or zinc oxide given? Yeah, we have aluminum oxide over here, so it's going to be aluminum oxide. And you should know that they can react with both acids and bases. Okay, is a good conductor of electricity when solid. Okay, so good conductor when solid. What are we talking about? Two things can be a good conductor in solid. Either it can be a metal or it can be graphite. These two are good conductors in solid. So over here we have no metal, we have only graphite. So the answer is gonna be graphite. Okay, contains a simple molecule with 9 atoms. Okay, so firstly we have to figure out simple molecule and then we have to find those that have 9 atoms. Okay, so chlorine is a simple molecule, ethanol is a simple molecule, then nitrogen is simple, oxygen is simple, propane is simple, and propene is simple. Okay, so chlorine formula is Cl2. It has only 2 atoms. Ethanol is C2H5OH. Okay, so chlorine, it has 2 atoms. Let's count for ethanol. Ethanol has 2 plus 5 plus 1 plus 1. So 2 plus 5 plus 2, 5, 6, 7, 8, 9. So ethanol is going to have 9 atoms. So the answer for this one, that is simple molecule with 9 atoms, is going to be your ethanol. React together to form slag in the blast furnace. We know, even if we don't read the options, we have done the blast furnace so good that we know it's going to be calcium oxide, which is a basic oxide. Okay, you should know this, that this one's a basic oxide. And then we have our very own silicon IV oxide, and you should know that this basically acts as a acidic oxide. So done. Belongs to the homologous series whose general formula is CnH2n plus 2. Basically, this is the general formula for alkanes. For alkenes, the formula is CnH2n. So this is for alkenes and this one's for alkanes. Plus 2 means there is going to be alkane, and there's only one alkane given, that's propane. It is manufactured by the catalytic addition of steam to ethanol. If you add ethene to steam, you're going to form ethanol. And if you add propane to steam, you're going to form propanol. If you add butane to steam, you're going to form butanol. So if you add an alkene to the steam, you form the alcohol. It's a gas that is approximately 78% of clean dry air. We know that this gas is going to be nitrogen. And if they ask that a gas that occupies 20%, it's going to be oxygen. And if they say 0.04% is going to be carbon dioxide. I hope you get it. Next question states that Atoms are made up of electrons, neutrons, and protons. State which of these particles are found in the nucleus. I guess that's basic enough. That needs no explanation. That neutrons and protons are found in nucleus, and these two together are also called nucleons. Okay. Atoms of the same element are known as isotopes. Okay, you have atoms of the same element, you know they're isotopes. Sulfur 32 and 34 are isotopes of sulfur. Complete the table to show the number of electrons, protons in one atom of or ion of these isotopes. Okay, so first, the electrons in an atom of sulfur, this number, that's 16, basically tells us that that's the proton number. So protons and electrons in the atom are going to be same. For neutrons, it's going to be 34 minus 16. So 34 minus 16, it gives me 18. So 18 neutrons. For a sulfide ion, the protons are always going to be same, but for electrons, they're going to be 2 more electrons than protons because there's a 2 negative charge. So the number of electrons are going to be 16, 17, 18, and the neutrons are going to be it's going to be 32 because over here we have a 32. You can see it's a 32 nucleon number, or you can say the mass number. So 32 minus 16, that's going to give me 16. Done and dusted. Table 2.2 shows the relative masses and the percentage abundance of the two isotopes in the sample of sulfur. Okay, so we have to calculate the relative atomic mass for the sulfur to 1 decimal place. What do we do for relative atomic mass? We take this mass multiplied by the percentage, which is 32 times 95, plus we take the second mass, which is 34, multiplied by the percentage, which is 5, upon the sum of percentages or the abundances, that's going to be 100. You know, 95 plus 5 is going to give me 100. So 32 times 95, 32 times 95 plus 32 times 95 plus 34 times 5. So plus 34 times 5 divided by 100, and we get 32.1 as our answer. Okay, the relative atomic masses of all elements are compared to one atom of an isotope. Identify the isotope. Obviously, we know it's a carbon 12. Basically, it's a carbon 12 isotope to which the masses of all other elements are compared. You know the definition of a relative atomic mass. The mass of one atom compared to the atom of carbon 12. Okay, ions are atoms or groups of atoms that have gained or lost electrons. We know it. An oxygen atom has electronic configuration of 2,6. That's for oxygen atom. Ion is going to be 2,8 for an oxide ion. Give the formula one atom and one positive ion. Okay, one atom, one positive ion that has the same electronic configuration as a O2 negative. O2 negative means electronic configuration of O2 negative is 2,8 because this 6 is the electronic configuration of the last shell, and now it has gained 2 electrons. It's going to be 2,8. So an atom that's going to have electronic configuration of 2,8 is going to be a neon atom, because in total we're looking for 10 electrons. And a positive ion that's going to have the electronic configuration of 2,8, go to the periodic table, it's going to be a sodium ion. And to explain this to you guys, I show you that, look, sodium has 11. It can be sodium ion, it can be magnesium ion as well, but sodium, let's do for sodium right now. Sodium has 11 protons, and when it's going to lose one electron, it's going to form Na positive 1, and now it has a total of 10 electrons because it has lost one electron. So a sodium ion is going to have electronic configuration of 2,8. So the positive ion, I'm going to write Na positive ion. I have to give the formula. For neon, it's this, or you can also write Mg2 plus, or you can write Al3 plus, because after losing these 3 electrons, aluminum also has electronic configuration of 2,8. Done and dusted. Zinc is held by the electrostatic force of attraction between the particles. Name the type of bonding present in zinc. That is metallic bonding, because zinc is a metal. And how does it have electrostatic forces? There are positive cations, and there are delocalized electrons, and their force of attraction between these ions and these electrons are electrostatic forces. Okay, name 2 types of particles that are held together by the bonding. You have your cations, you can say, or you can say they are also called the positive ions, and the second particle is the electrons. And between these, you can it's a better word if you use the word delocalized electrons, because they are basically delocalized. So delocalized electrons and positive cations. Okay, name the type of particle whose movement allows zinc to conduct electricity. Electrons. Why? Because zinc is a metal, and what's going to happen is that these electrons, they can move through the structure like this. They're going to move and they're going to conduct electricity. Zinc is present in alloys such as brass. We know. State the meaning of the term alloy. Alloy is basically a mixture of 2 or more it's a mixture of two or more metals, or you can say non-metals. Okay, so when you're basically combining two or more metals, for instance zinc uh, is present in alloy, which is brass, and brass is not only made up of zinc. There's an other element in brass, name the other substance that is present in brass, and that is copper. So if you mix copper metal and you mix zinc metal, so what are you going to form? You're going to form brass. And why do we form alloys? We form alloys because alloys are harder and stronger than pure metals. Okay, zinc sulfate crystals are made by the reaction between zinc carbonate dilute sulfuric acid. Okay, we know what we're going to do. Give two observations which show that the zinc carbonate is in excess. It's in excess because firstly what's going to happen when you're adding zinc carbonate? What do you see? You see effervescence. So you write that effervescence, effervescence stops on adding more ZnCO3, because what's going to happen? You have this container, you have your water in your container, and when you're adding your zinc carbonate in this container, you should see effervescence. But since it's in excess, so what's going to happen there? It's going to settle at the bottom, and even if you continue adding more, there's not going to be any effervescence. So you get it? So the first point is going to be that you don't see any effervescence, and second point, it's going to be in excess, so it's going to be settling at the bottom. So you can write that zinc metal settling at bottom. Okay, that means that it's basically like just there and it's not reacting or doing anything. Name the filtrate in step 2. Okay, so what are you going to do? The filtrate is obviously going to be zinc sulfate. Why? Because when you're mixing, this is sulfuric acid. Okay, so basically this is sulfuric acid, H2SO4, and you have added zinc carbonate to sulfuric acid. So what are you going to form? You're going to form zinc sulfate, and when you form zinc sulfate, that's going to be a filtrate. Filtrate is basically something that's gonna filter out because it's soluble, and the zinc oxide or zinc carbonate, whatever it is, zinc carbonate, it's going to remain as the residue on the filter paper. So when you're going to filter this mixture, this liquid thing that you're going to get is going to be your zinc sulfate. So you can write the full word. I've just written the formula. Okay, name a compound other than zinc carbonate which can be added. You can add zinc oxide, but what can you not add? You cannot add zinc nitrate. Why can't you add zinc nitrate? Because this is soluble. If this is soluble, then there's going to be no residue over here. If this is soluble, all will dissolve. We don't add any soluble things when we are adding things in excess. Why? Because we need to filter this out. If it dissolves, we're gone. Our salt is going to be contaminated by zinc nitrate. We're not gonna form zinc. We are gonna form zinc sulfate, but that's gonna be extremely contaminated by zinc nitrate, which we don't want. So we cannot use anything that's soluble. Okay, state what is meant by the term saturated solution. Saturated solution means in which you have your maximum amount of solute dissolved in a solvent, and you have to make this thing sure at a specified temperature. Why at a specified temperature? Because if you increase the temperature, the solubility is gonna increase. You have to keep the temperature fixed. You can't just keep on increasing the temperature, okay? Because otherwise, then if you're increasing the temperature, solubility increases. That doesn't mean anything. And one problem over here, some people might consider this saturation as a carbon-carbon single bond, which is not what they're talking about. A saturated solution and saturated hydrocarbon, two different things, okay? Step 1 is repeated using large pieces of zinc carbonate instead of powdered zinc carbonate. Okay, so if you're using large pieces, you know your rate of reaction is going to be slow. Explain why the rate of the reaction decreases. Because large pieces, they're going to have a less surface area. Otherwise, if you have powder zinc like this is going to have much more surface area, because less surface area, write full surface area. Okay, I'm just writing. Okay, good. Less surface area, less collisions of reactant molecules. They're going to be less successful collisions because there is less area exposed. So frequency, this is a key word. You need to always write frequency of effective collisions decreases. okay, collisions decreases. Because over here, for instance, this is the particle that's going to react with it. Over here, the particle can only react with this surface, okay, only from outside. But in this conditions, when you have this powdered thing, it has a lot of surfaces to collide on. So that's the thing that is concerning over here. Okay, hydrated crystals form in step 4. State what is meant by the term hydrated. Hydrated is basically a salt that is chemically combined with water. Okay, that's very important word. Okay, hydrated means when you are chemically combined with water. And that's why for hydrated salts, for example, CuSO4.5H2O, this is a hydrated salt. For hydrated salt, there's one important thing. In their formula, you add this 0.5H2O. Why in their formula? Because this is when you're chemically combining, okay? Adding water to something and having a hydrated salt are two different things, okay? Over here, you are chemically being combined, okay? This question is about the compounds of sulfur. Sulfuric acid is made in 4 stages. Okay, stages are listed. Balance the symbol equation for this reaction. Okay, I need to balance the equation. What do? I have 4Fe. Okay, if I have 2, so I added 2 over here. I have 4 2s are 8. 8 sulfurs on this side. So I add 8 over here. How many oxygens I have on this side? 4 2s are 8 2s are 16 plus 2 3s are 6. 16 plus 6 gives me, I guess, 22, right? 22. I have 22 oxygens on this side and 2 on this side. So I add 11 over here. Done. Okay, complete the dot and cross diagram to show the electronic configuration is an oxygen molecule. Simple. They're going to be 2 double bonds like this. I don't even need to explain this. That is so easy. And then you just fill the electronic configuration. But you keep in mind to put these lone pairs of electrons as well. Why do you put these lone pairs of electrons? Because you have to draw the full electronic configuration. You have to show the full outer shell. Okay, state the 3 typical conditions for the reaction between sulfur dioxide and oxygen in stage 3. Firstly, 3 typical conditions. They're listed in your I guess I should open the syllabus, because otherwise you guys are gonna think that syllabus, Cambridge, IGCSE, it's all mentioned in the syllabus. Okay, you have to learn it from the syllabus. The best thing is to learn it from the syllabus. I'm going to show you where is this listed. Basically in the metallic bonding. No, it's in the chemical energetics chapter. Yeah. Okay, state the sources, state the typical conditions for Haber process. That's very important. Just learn these 3 conditions and the typical conditions for the contact process. Okay, that are 450 degrees Celsius, 2 ATM and vanadium oxide. Okay, learn these from the syllabus. Just learn the entire syllabus, I would say. 2 ATM, 450 degrees Celsius and vanadium oxide. So it's 2 ATM, 450 degrees Celsius and V2O5 catalyst, temperature and pressure. Okay, done. Write a simple equation for the reaction that occurs in stage 2. What's happening in stage 2? Sulfur dioxide reacts with oxygen to form sulfur trioxide. Okay, so simple equation, sulfur dioxide reacts with oxygen to form sulfur trioxide. But you should keep in mind that this is a reversible reaction. So we can do something like this, and then we put a because oxygens, are they balanced? No, they are not balanced. So we put a 2 over here, a 2 over here, and then we have 4 on this side and 2 3s are 6 on this side. So I guess now it's balanced. Is it balanced? Yeah, it's balanced. Okay, good. Write the simple equation for the reaction in stage C. What's happening in stage 3? Sulfur trioxide reacts with concentrated sulfuric acid to form oleum, which is H2S2O7. So forming H2S2O7 O7, and basically we have sulfur trioxide, which is reacting with sulfuric acid to form this thing. Okay, I guess we're balanced. We're completely balanced. We don't need to balance it. You can see it for yourself. Okay, sulfuric acid reacts with carbon. The equation for the reaction is shown. Give the oxidation number of carbon in carbon. When you have a free element, oxidation number is 0. And in carbon dioxide, because oxygen is a -2 and we have 2 oxygens, so -2 times 2 is a -4. To balance out a -4, the carbon needs to have a +4. So it's going to have a positive 4. Okay, so now we have to calculate some moles. Okay, dilute sulfuric acid reacts with sodium hydrogen carbonate to produce carbon dioxide gas. Okay, we have the reaction. 4.20 gram of NaHCO3 is added to excess dilute sulfuric acid. Okay, calculate the volume of carbon dioxide measured RTP. Okay, they've given us the steps. Let's follow the steps. Calculate the number of moles of this in 4.20 gram. Okay, moles equals to, this is the mass upon mr, 4.20 divided by 84. Okay, 4.20 divided by 84, and that gives me 0.05 moles. Okay, next step says reduce the number of moles of carbon dioxide. Okay, we need to, for this we need to check the ratio. You see that sodium hydrogen carbonate ratio carbon dioxide, over here it's clear and visible that it's a 2:2. So the number of moles of carbon dioxide and sodium hydrogen carbonate are going to be the same because it's a 2:2. So it's a 0.05 moles of this as well. Calculate the volume of CO2 produced. 1 mole occupies 24,000 cm cube. Okay, so what do? You multiply the moles with the volume occupied by 1 mole like this, and multiplied by 24,000, and we get 1200 cm cube. That's going to be our volume. Done and dusted. Ethanoic acid is manufactured in the reaction between methanol and carbon monoxide. At equilibrium is produced. Take two characteristics of equilibrium. You should know this. Rate of forward reaction equals to the rate of reverse reaction, and the second is that your concentration of reactants and products remains unchanged. Of reactants and products remains, you should learn these, remains unchanged. Okay, done. Both a high yield of ethanoic acid and a high rate of high yield of ethanoic acid and a high rate of reaction are needed. The reaction is carried out at 300. Okay, you know we're not given either it's exo or endo. Leave it, the forward reaction is exo. Okay, so now we know the forward is exo, and when we know the forward is exo, we also know one thing, that the backward is going to be endo. Okay, we have 2 moles on the reactant side and 1 mole of gas on the product side. Okay, so if we increase the pressure, the equilibrium is going to move towards this side because this side has less moles. If we increase the temperature, equilibrium is going to move backwards. These things are important. Below 300, state the disadvantage of using a temperature below 300. Okay, we're using a very high temperature, though this is an exothermic reaction. So you might think that using a high temperature would decrease the yield, but we need a faster rate as well. Over here they've mentioned that the rate needs to be faster. So if we use below 300, the rate is gonna be slower. The rate is gonna be, don't write gonna be, right? The rate is going to be slower. Above 300 degrees Celsius, yield of ethanoic acid is less. Yield of ethanoic acid is less. How do we know the yield is going to be less? Because this is an exothermic reaction. If it's an exothermic reaction, increasing the temperature would mean that reaction moves backwards. Okay. Complete table 5.1 using only 3 words. Increases, decreases, or no change. Catalyst is added. Catalyst does not affect the equilibrium yield. Just remember this thing. Effect on the rate of the forward reaction. Obviously, rate increases, but on the concentration of ethanol, methanol, whatever, there's going to be no change because catalyst cannot affect the equilibrium. Pressure is increased. Pressure increased. So I told you, pressure is increased. The equilibrium move towards the side that has less moles. So it's going to move forward. So equilibrium, when it's going to move forward, the equilibrium concentration increases, and effect of pressure on the rate. Pressure and rate are directly proportional. So rate is also going to increase. Okay. Suggest which element in the list is a suitable catalyst. Obviously cobalt. Why? Because because it's a transition element, and you know that all catalysts are transition elements. This is group 2, this is group 1, this is group 4. This is non-metal, these are 2 metals. We need a transition element for catalyst. Okay, ethanoic acid is a member of the carboxylic acid homologous series. Name the carboxylic acid that contains only 1 carbon. You know, we are talking about methanoic acid. Methanoic acid contains only 1 carbon. Meth, eth, pro, bute, just learn it. State the molecular formula for carboxylic acid that contains 4 carbons. So it's going to be C3. It's going to be C3H6COOH. So that's the That's the formula. And if you want to write the molecular formula, it's going to be C4H C4 C3H, not 6, sorry, it's 7, C4H8 H8O2, like this. What do? You simply double the hydrogens and oxygen remains O2. Draw the displayed formula of the ester which contains 2 carbon atoms. Okay, so the ester which contains 2 carbon atoms, so it's going to be between methanoic acid or ethanol, or ethanoic acid or methanol. Okay. Carboxylic acids react with alcohols to form esters. Draw the displayed formula of the ester which contains 2 carbon atoms. Okay. This done. This is methyl methanoate. Sorry, that ethanol thing that I was saying previously, just forget it. We can only form methyl methanoate from this. Okay, propyl butanoate is an ester named the carboxylic acid, and the alcohol carboxylic acid is going to be butanoic acid. Alcohol is going to be propanol. So alcohol is propanol and carboxylic acid is going to be your butanoic acid. And how do I know it? Because butanate part comes from the acid, propyl part is coming from the alcohol, and organic compound is the formic composition. Okay, we have to calculate the empirical formula. Okay, so what are we going to do? Carbon, hydrogen, oxygen, 58.82, 9.80, 31.38 divided by their masses. Okay, 58.82 divided by 12. Okay, 58.82 divided by 12, that gives me 4.9. So here's a 4.9, here's a 9.80, ratio 31.38 divided by 16, 31.38 divided by, what am I doing? 31.38 divided by 16, and that gives me 1.96, which is 1.96, which I'm gonna divide all this by 1.96. That's the lowest number. 1.96 divided by 1.96, 4.9 divided by 1.96. So 4.9 divided by 1.96, and that gives me 2.5. Okay, so this gives me 2.5. This is gonna give me 9.80 divided by 1.96. 9.80 divided by, this gives me a 5, and ratio 1.96, this is going to give me a 1, but we have a problem. This is exactly in the middle. So what do? I multiply all these with 2. Why do I multiply with them 2? Because I cannot write 2.5 in the empirical formula. So I multiply this entire thing by 2. 2.5 times 2, 5. 5 2 times 10, and this becomes 2. So this is going to be my empirical formula, which is going to be C5H10 O2. And what kind of substance is this? If you look at the formula carefully, you realize this is pentanoic acid. Okay, so it's going to be C5H10O2. Why did I multiply by 2? Because I cannot write C2.5. Why cannot write 2.5? Because that's exactly in the middle of 2 and 3. I cannot write middle numbers. I need to either shift on the backward or the forward number. So I shifted on a number by multiplying it with 2. So the entire equation, or all the things got multiplied with 2. Okay. The questions about periodic table state the name given to group 1 elements. Without doubt, they're going to be called alkali metals. State which group 1 element is least reactive. It's going to be lithium, because reactivity increases down the group. So it's lithium, sodium, potassium, rubidium, cesium, francium. Okay, so down the group the reactivity increases. The most reactive is going to be this guy, and the least reactive is going to be this one. Okay, lithium is in group 1 of the periodic table. Lithium is added to water. State 2 observations. Okay, so do you know the reaction of group 1 metals with water? You're going to form lithium hydroxide and you form your hydrogen gas. You guys should know this thing. So now, one thing over here you need to know is that you're forming a gas. So what are you going to see? You're going to see effervescence, and you're adding a solid lithium to it. The solid is going to disappear. Okay, disappear. Write a simple equation for this reaction. Okay, we've just written it down. Pick it up, paste it here, remove the excess things, down. Okay, group 1 elements have lower melting points and lower boiling points than transition elements. Describe 2 other physical properties of group 1 element that are different from transition elements. They have a low density. Group 1 elements are going to float on water. And the other thing can be they have low melting points, low boiling points, they have low densities. You have to consider physical properties. So, catalyst should we consider? No. Let's consider that they don't form colored compounds. Don't form colored compounds, because you know that transition elements are going to form colored compounds. Okay, group 5, 6 and 7. So okay, group 7 is known as halogens. We know it. Give the physical state and color of chlorine at room temperature. State is going to be gas, chlorine is gas. The color is going to be green, yellow. Learn the colors for all. Fluorine is going to be a greenish kind of gas. Chlorine is going to be a green yellow gas. Bromine is going to be a red liquid. And iodine is going to be a grey black solid. Okay, when chlorine is passed through aqueous potassium bromide, we know that chlorine is going to displace bromine. Why? Because chlorine is more reactive than bromine. So that's what's happening over here. Write the ionic equation. Ionic equation for this is simple. Simple. Don't look at this. Don't even look at this. You have a chlorine, okay? And you're making it reacting with bromide ions. Okay? You have a chlorine, making it react with bromide ions, and you form a bromide, okay? Bromide balance plus 2 chloride ions. Chlorine displacing bromine to form bromide in 2 chloride ions. Okay, add in chlorine reactor to high temperature to form iodine. Okay, done, whatever. Right, the equation for the reaction is this. The equation, enthalpy, bond enthalpies are given. Okay, right. Okay, so over here we just have to calculate the total amount of energy to break 1 mole of I2 and 1 mole of Cl2. It's given. 1 mole of I2 would mean that it's 150 and 1 mole of Cl2 would mean it is 242. So 150 plus 242, let's check out what do we get. 150 plus 242 and we get 392 kilojoules per mole. The total amount of energy released when bonds are 2 moles, okay? This is kilojoule per mole. This is 1 mole of ICl. We need to find for 2 moles. So 2 times 218. Okay, so it's gonna be 2 times 218. And 2 times 218 gives me 436. So we have a 436 kilojoules per mole energy over here. Calculate the enthalpy change. We simply take the energy used to break the bonds minus the energy that was released when bonds were formed. 392 minus 436. So 392 minus 436 and we get negative 44. Okay, so now we're done with the paper, I guess. Hope you liked the video. Subscribe to the channel and thanks for watching, and that's gonna mean a lot. Bye bye.